Let's take a look at this example. First, we're supposed to redraw the circuit, or we can say supposed to just invisible things, invisible components or connections we have to make visible, okay? So let me remind you, anytime you are going to see 0 volts, right, next to the input terminal, it means that this terminal, okay, I'm going to draw by the dash line, but this dash line means the actual connection, right? But you have to just realize that this connection is not on the diagram, but it has to be in your mind, okay? This is basically what you're supposed to understand. So anytime I have 0 volts, there is connection between this point and ground. Anytime you are going to see like negative voltage, like in this case negative 5 volts, it means that you have voltage source connected to the diode by negative terminal, okay? Voltage source which has voltage, right, across of it 5 volts. So I'm going to at this moment erase this negative 5 volts and 0 volts to avoid the confusion. Next, we're supposed to analyze this circuit. So we have to find output voltage. Output voltage is the voltage between this terminal, output terminal, and ground. First, try to look for the connection, right, or the path which has no resistors, right, if you are going to be on the way to the ground. So if you are going to go by the diode to the ground, you are not going to have any resistors, right? See, we have just the diode and we have voltage source. Okay, so we can find very easy V out. So because the voltage source is connected by negative terminal to the diode, right, and positive terminal to the ground, it means that the current is going to go counterclockwise, theoretically, because we're supposed to find if the diode is on or off. So theoretically, this voltage source is going to push the current in this direction, counterclockwise, okay? And please notice the direction of my current will be exactly the same like the direction of the arrowhead of my diode. So it means that this diode is going to be in the on state. In on state because the voltage source is much greater than 0.7 volts and the direction of current is matching the direction showed by the arrowhead of the diode symbol. So this diode is for sure on. Okay, so if you want to find output voltage, this is equal to, we're supposed to write this down, V out is equal, and before we are going to write the equation, you have to remember that anytime the current is entering component, I'm supposed to write positive, anytime it's leaving, I'm supposed to write negative. So I have positive VD2 minus voltage source. This is equal, because this is silicon diode, I'm going to write over here 0.7 volts minus 5 volts. This is equal negative 4.3 volts. So my output voltage is equal negative 4.3 volts. But someone is going to ask, but wait a minute, we have another diode. But please notice that this diode, right, is connected to the ground, right? Connected to the ground, and we found that the voltage between this point and ground is negative 4.3, right? And cathode of the diode is connected to the ground. Now, please notice that negative 4.3 is much lower potential than 0, right? So this diode is going to see that we have higher potential at the ground than at the anode of the diode, right? I mean ground, which is connected to the cathode. So cathode has higher potential than the anode. So it means that the diode is in the off state. The diode is not conducting, is behaving like an open circuit. That's why I concentrate only on this part which has the voltage source, right? So we don't worry about this diode, and we are going to concentrate just on this part of the circuit. So what we're supposed to find next? We're supposed to find IR. IR is the current which goes through this resistor. IR is the current which we are going to find by using Ohm's law and dividing the output voltage, because output voltage is the voltage across this resistor, divided by the resistance of this resistor. So I can simply write that IR is equal voltage across the resistor over R, or we can say this is nothing else, just V out over R, where V out we found is equal negative 4.3 volts. Anytime I write VO or V out, this is the same thing, over R, 2 kilo ohms. This is equal negative 2.15 milliamps. Okay, so this is the current which will go through the resistor. As we said, this diode is going to be in the off state, so we're not going to consider the top part of the circuit. So we can say that the current which goes through the resistor is equal to the current which goes through the diode. So I can write that IR is equal to ID2, right? And this is equal negative 2.15 milliamps, and because the diode 1 is in the off state, is behaving like an open circuit, so current cannot flow, okay, through it. So we have ID1 is equal to 0 amps. Okay. Next, we're supposed to find the power at the resistor, right? So we're supposed to write the formula: power is equal IR squared times the resistance, which is equal negative 2.15 milliamps raised to the second power times the resistance, 2 kilo ohms. Everything is equal 9.24 milliwatts. Okay, so we can say that the problem is solved.